I'm sure most .NET developers are familiar with LINQ, the idea of language integrated query. That is essentially a collection of operators that you can do on an IEnumerable to quickly get a query out of it. For example, summing up all the elements or finding all the elements fitting a specific criteria. And you can build these large LINQ chains. But the thing about LINQ is it's single thread. And if you have lots of data to process, you might want to parallelize some of the parts of the processing of this data. So let's take a look at how it works. It's actually very simple. Let's have a bunch of elements. I'll have, let's say, 50 elements, and then I'll generate an array which contains numbers from 1 to 50. So I'll say var items equals enumerable dot range, going from 1 to count in this case, and we need an import here, and we'll do it to array. So this is not parallel LINQ yet. This is ordinary LINQ. You can use system LINQ here, and enumerable.range just generates a set of numbers. We've seen it before, but now what I want to do is, let's suppose I want to calculate the cube of each of the values. So I'll have a placeholder called results, which is going to be an integer array once again with count elements. And here what I'm going to do is I'm going to calculate the cube of each value, but I'm going to do it in a multi-threaded setting, which means that the 50 elements that we have are going to be split into several clusters, and those will be executed by different tasks, and the process of executing them will still be orchestrated by LINQ. So in a typical scenario, what you would do if you were using ordinary LINQ is you would say something like items dot select, and then for each of the items you would go ahead and calculate the value. But we're going to do it differently. We're going to parallelize this loop. And in order to parallelize the actual execution of the LINQ query, what you do is, as soon as you get the items, you specify that you want to process them as parallel. So this is an extension method which returns a parallel query. So as soon as you're done invoking that, instead of having an ordinary IEnumerable, you're then working with a parallel query of T. In this case, this would be a parallel query of int, because we're creating a range of integers. So this is really all of parallel LINQ. It's this one call AsParallel, and from then on you can continue using the operators you used to. Now in this case, we don't want any return values, so instead of using select or something like that, we'll use a for all. So a for all has no return value because we have a placeholder for results where we're going to place the results. So we're going to take each of the elements x, and these are the values from 1 to 50, and we'll actually calculate the new value. So we'll say new value equals, let's say, x cubed, and then I'll do some write line once again so that we can see what's going on. So I'll write line that here is the new value, but in addition, let's actually write the task ID just so we can see what's going on. Plenty of imports required here, so task.currentID in round brackets. I'll put a tab at the end of it, and we'll do a task.write instead of a write line. We don't have that much space for 50 items, so I'll do a task.write, and then we write the results. So we say results at x minus 1, because remember x starts with a 1 and arrays start with a 0, so results at x minus 1 is equal to new value, and that's it. We've calculated our results, but we've calculated them in a parallel setting. So let's now actually execute this. I'll put a write line here, and let's execute this and see what the results of the execution happen to be. Okay, so as you can see, we have the results all over the place. You were maybe expecting the 1 to appear at the beginning, but in fact, it's all kind of mixed. And you can also see that we have, what is it, 1, 2, 3, 4, 5, at least 5 different tasks working on the 50 elements of data. So here is the overall layout. As you can see, it's very chaotic because, once again, as soon as you run something in parallel, you no longer control the ordering, but of course the results are placed in the correct location. So we can maybe output the results. Let me do another write line here, and then for each of our I in results, we'll output the results tab separated once again. So I will write line the element I followed by a tab here, and then do another write line at the end. So we can now look at the results, and we can see that even though the execution which we saw was totally out of order, the actual results are, sequentially growing because we wrote them to the correct cells. So in this fashion, we've basically executed the sort of mapping operation, mapping each item to this item cubed and writing it into results. And we've done it in a parallel fashion using Parallel LINQ. And the crux of Parallel LINQ is this AsParallel call. That's all that there is to it. Now let's actually look at something else. As you can see in this example, what we did is we processed the items, but we didn't process them in any particular order. So let's see if we can do it differently. Let's see if we can impose some ordering on the processing, because if I run this again, let me comment out the section with the actual results. If I run this again, and if you look at what we're getting, you can see that the items are not processed in order. They're processed kind of all over the place. For example, the element 1 is processed after a bunch of elements have been processed already, and you can get them to be processed concurrently but in a sequence. So this is something that you can set up as well. Let me show you how that would work. So you would say var cubes equals items.AsParallel. We've seen that before, but then you can also specify as ordered. So this basically means that even though it's still a multi-threaded setup, it's still a bunch of tasks processing different chunks of your data, what will happen is the elements will be taken sequentially and processed in a sequence. So in this case, once again, we can do a select. So I can select for each element x times x times x. So I now have a bunch of elements in cubes, and once again for each var I in cubes, what I can do is I can sort of copy what we had here, just uncomment it, and output each of the elements, and let's do a write line at the end. So in this case, the most interesting part is how they are ordered in terms of the final result. So if we execute, you will see that once again the ordering I'm getting is a growing sequential ordering. So you can see that even though the elements have been kind of all over the place, actually let me remove the right here. I'll remove the right so we can see the line part, so we can see them horizontally on the screen. So you can see that they're growing. Now if I were to remove the as ordered part, what would happen is the sequence would still contain the same elements, but it would contain them in absolutely unpredictable order. So you can see that right now they are all over the place. The 1 is not at the beginning, and then smaller elements after larger elements. So if you want the ordering at the end, then you have to specify as ordered. And specifically also, if you have a sub calculation that you want unordered, you can also specify as unordered. So you can, for example, process some of the elements in an ordered fashion and then process them in an unordered fashion. So you get this kind of control over how the elements are processed. Now, just like with ordinary LINQ, you have to also realize that the evaluation of the results is delayed, which means that when you execute this statement, absolutely nothing happens. So cubes essentially just becomes a plan of execution, and you only calculate the items. So you only execute the items on separate threads when you enumerate the enumerable. So the idea is very simple. Whether you have an IEnumerable of T or whether you have a parallel query, the actual calculation of the items, all the selects and whatnot, they only happen when you go and either enumerate the elements or you try to materialize them. So you try to, for example, turn them into an array. So if you do to array, this is where all of the items would be calculated.